at compute inverse of f, where the f functions, okay, as a function of x is this ln x squared plus 9 over x squared plus 1. And second one is arc time 1 over 3. So how do we solve this question? I think in the first video we've explained that we've established that minus t f of t is equal to inverse of ddx of f of t. This has been established in the first video, and then we also note that this symbol is the same as what f of Laplace of f of t. So if you take the inverse of both sides, then you realize that the inverse of this function will give you what? Inverse of this will give you f of t. Yeah, if you take the inverse of both sides, that will give f of t, and that f of t we want to look into. Okay, so if you take an inverse of this, you get f of t. So without wasting time, we just start from here that we know that minus t f of t is equal to what? ddx of inverse of ddx of the function we are given, ln s squared plus 9 all over s squared plus 1. Okay, so that's that. Then what we need to do now is for us to get the differential derivative with respect to x of ln s squared plus 9 over s squared plus 1. So the thing is that you must be sound, you must be good in your differentiation. Okay, you must be good in your differentiation, and this just be equal to, we said in the first video that when you differentiate ln, it's very simple. It's going to be s squared plus 9, okay, over s squared plus 1. I'll put prime there, which means the derivative of this function over itself, the function itself, over the function itself. So that's what we said. So just apply that principle. Let's get the derivative of this, the function itself. So s squared plus 9 over s squared plus 1 prime will be equal to the derivative of that quotient rule, that will be s squared, because this is a fraction, and that call for quotient rule, s squared plus 1 all squared. Okay, then v is s squared plus 1. The v is a denominator times the derivative of the numerator, which is what? 2x. Then minus the numerator, s squared plus 9, times the derivative of the denominator, which is what? Which is 2x. Okay, and this will give us 2x cubed plus 2x. If we expand that, and that will also give us minus will comes in, that will be 2x cubed minus 18x all over s squared plus 1 power 2. So this will cancel out. To cancel out, then we have 2x minus 18, and that will be minus 16. That will be minus 16x all over s squared plus 1 all squared. So we've done the differentiation now. So we need to do the finish the algebra. So we now come back here again and write again that ddx of ln s squared plus 9 over s squared plus 1 is equal to what you have here, minus 16. So don't forget what we said here, divided by the function itself. So with that, 2 times, then you flip that fraction, that will be s squared plus 1, s squared plus 9. So s squared is here, 1 is here, 2 is here, so we have minus 16x. Yeah, minus 16x all over. To remain 1 here, that will be s squared plus 1 into bracket s squared plus 9. So that's what we have there. So we finish that ddx of that functions. So the final thing to do now is to just go back to the formula minus t f of t equal to this. Yeah. So, and that will be equal to inverse of this minus 16x over s squared plus 1 s squared plus 9. So that's what we have. Then let's get the inverse of this. Let's get the inverse of this. You can take the 16 out. That will be 16. Inverse of minus 16 out. X over s squared plus 1 s squared plus 9. So that's what we have now. Inverse of that. Then we can solve this using partial fraction. We can solve. Let's take this one out. X over s squared plus 1 over s squared plus 9 will be equal to, this is quadratic expression, that will be ax plus b all over s squared plus 1, then plus. The other one also will be cx plus d over s squared plus 9. So they multiply 2 by these, the denominator here, multiply both sides by this denominator, these two expressions. And that will give you this equal to ax plus b into brackets s squared plus 9, then plus s squared plus 1 into brackets cx plus d. So what can we do now? Let's expand so that we can equate the coefficients. This one times this one, we have this. This one times this one, we have 9ax b x squared. Then b times 3 times 9, that's 9b. Then plus s squared times 3 is cx, that's a cs cube plus dx squared plus cx plus d. So let's begin to equate coefficients. Coefficient of s cube will give us a plus c equal to 0. We don't have s cube on the left hand side. That's equation 1. S squared coefficient, it will be equal to, here, we've done this one, we've done this one. That will be b plus d equal to 0 2. Out of x, coefficient of x, that will be 9a, this one, plus c equal to 0, equal to 1, equal to 1. So we have it here, coefficient of x here is 1, equal to 1. And then the cosine terms, do we need that? I don't think we don't need that thing. Okay, let's get the cosine terms. For the cosine terms, we have 9b plus d equal to 0. Okay, so we can solve equation 1, equation 2, equation 3, equation 4. We can combine 1 and 3 together. So 1 and 3 together, so equation 1 times 9. So equation 1 times 9 will give us 9a plus c equal to 0. Then equation 3 is 9a plus c equal to 1. Can you subtract the equation? Subtract the two together. So that will be equal to 9a, no, equal to 9. Equal to 9. Equation 1 times 9, that's 9a plus 9c. Okay, then combine with equation 3, 9a plus c equal to 1. Equation 3 is 9a plus c equal to 1. This equation 1 that we multiply by 9 so that we can have the same coefficients for a, and a can cancel out. Okay, so 9a plus 9c equal to 0. Then equation 3 is 9a plus c equal to 1. Okay, then we can subtract, this will be 0, this will be plus 9c minus c, that's 8c equal to minus 1. C is minus 1 over 8. Okay, then we can go to equation 1 and substitute there. A plus c equal to 0, and then c is what? Minus 1 over 8. Okay, equal to what? 0. So a is also what? 1 over 8. We've gotten that 1 over 8. Then we can combine equation 2 and 4 together. We can combine equation 2 and 4 together. Equation 3 is b plus d. B plus d. Can you multiply that one by 9 also? By 9 also. So we have 9b plus 9d equal to 0. Equation 2 times 9. So combine with 4. And 4 is 9b plus d equal to 0, 2. Then subtract the two equations. Then we have 8d equal to 0. So d is what? D is 0. Okay? Then with that, we can go to equation 2. 8 plus d equal to 0. Equation 2. Then d is 0. Equation. Then go to substitute into 2. b plus d equal to 0. So b plus d, which is 0. So equation b also is also 0. So d is 0, b is 0. Then we can come back to where we stop there. Minus t, f of t equal to minus 16, inverse of we have the expression which is inverse of x over s squared plus 1 into brackets s squared plus 9, which is equal to minus 16 into inverse of we said is for the clinics we call it ax plus b. A is what? A is 1 over 8, okay, plus x. Our b is 0, all over s squared plus 1, okay, then plus. We also have cx plus d. C is what? C is minus 1 over 8. So minus 1 over 8. And d is 0. Okay, all over s squared plus 9. Okay, so now we equal to minus 16. We can take the 1 over 8 outside. 1 over 8 can be taken outside. The inverse of x over s squared plus 1. And then see, open the brackets. Then minus 1 over 8 inverse of this x over s squared plus 9. Okay, and this will be equal to minus 16 over 8. This will be cos t, and here will be minus 16. Okay, that will be plus over 8, and this also will be cos 3t. So that's equal to minus 2 cos t plus 2 cos 3t equal to what? Equal to minus t f of t. So f of t is equal to minus 2 cos t plus 2 cos 3t all over minus t. So that's the answer to that question. That's the answer to that question. Okay.